Yang. So the last couple times I was always referring to the CLI as the legacy way how we deal with the network devices. So there must be kind of a newer thing, not extremely new, but yeah, a little bit newer than CLI. CLI always the same for the last 30 years probably. And now we have, I think since 2008, we have Yang and NetConf. Now we also have RESTconf, gRPC to communicate with network devices. So this is an API focusing on automation or programmability for machine-to-machine communication. So last time we talked about screen scraping and all the pain we have with it. And the idea would be that we would have less pain with Yang. Don't get me wrong, I think Yang is at the moment the best way we have to interact with the network devices, but it's, in my opinion, still far away from perfect. Yeah, it's kind of a complex modeling language. It has a lot of features, advanced features. Yeah. Do you know other data modeling languages? If you have an API nowadays, how is this API described? OpenA specification, yes. So have you dealt with OpenA API 3.1 or? Application architecture. Yeah, so if you have OpenAPI 3.1, for example, there is then JSON schema behind who describes the data who comes from the endpoint, right? So here what we have is something similar. We have a language who describes in what kind of format the data comes, how we can validate it, we can have constraints, all this stuff, different data types. So it is basically a description how the data has to look, how is the format. One thing we will notice pretty quick is that 2008 when this was designed, or we would have to see in the RFC when it started, the focus was definitely on XML. So the first version we would have was NetConf with XML communication. Yeah, so there was Yang, there was even Yin, or there is Yin and Yang. Yin, who is the transformation in XML, so we can also describe it in XML. Yang uses these curly brackets we will see. And a lot of stuff we will see is kind of close to XML, and we can also see that if you have dealt with XML APIs in the past, maybe you had XST, so XML schema, kind of the Bono to JSON schema, but for XML, kind of an old technology, and Yang just has a lot of more advanced features in it. So we have here basically the models who describes the data format, and then of course to communicate with a device we have a transport layer. In this case it would be, for example, SSH, it would be HTTP, or it could be anything. And on top we have the encoding. At the moment XML, JSON or GPB is the common ones. There is now, not sure if it's still a draft or not, who uses CBOR, binary encoded EATF version 4, definitely used in streaming telemetry. So if we want to get data from the device for monitoring. Yeah, so there are different encodings. On top we have different protocols, so kind of how we send the data with RPCs. And what we actually want in the end is to have an API where we can use it, and then in our applications, could be Python code, could be Go code, could be anything, we want to talk with these APIs, and we want to have structured data So today we will only focus in this 45 minutes about the Yang itself and only on the basics. So we will not go deep, we will just see a little how this language works, how it looks, what kind of features it has. And next time we will then talk more about the protocols like netconf, who uses it. So the goal is to have a basic understanding of Yang, how it works, and then of course we need to be able to read some simple Yang models. So in the end you don't have to write without any help Yang definitions by heart at the exam on paper. We will not do that, that's pain. But maybe there will be a snippet or something and you have to understand which XML is valid, which one is not valid, for example. Should be doable. So this will be a really simple example. So this file would have the module. So this is our Yang model we are doing, and this one is called my endpoint. And because it comes from the XML part, we always have a namespace. And we have a prefix. The prefix is used if we include this model in another model and we want to reference to something, we can use this prefix. Because we can also define our own data types, or we can include other data types, we can include other groups and reuse them, and then we need this prefix. Yeah. Then we have a container. So that is kind of, in XML language, it would be just the tags, and then inside we would have the specific tags with the values. Afterwards we will see always the kind of Yang components we have and how they would look in XML. On the module level, of course, we normally have some metadata like author, descriptions, revision numbers, what is changing. Everything can be in the top level, and then we can have containers, leaf for values. I hope you get the idea. And then if we, for example, visualize it with a tool in a tree kind of output, we can see that we have here an endpoint and we have one value name we can set. And this has to be a string from the type. Make sense? So, Yang itself, it is many times called yet another next generation data model language. However, in the official RFCs and in the history, I could not find this term. So I'm not sure where this name comes from, if it was always there. I found some drafts, RFCs who reference to Yang as yet another next generation, but I could not find an official document who really uses this name. So we will just call it Yang, and we will not care how this came to be Yang. Yeah, the RFCs, we have the 6020 and 7950. So this is actually version 1. This is version 1.1, and we have a Git repository who is kind of important to know because there are most of the Yang models available. So if we want to work with Yang models, we can go there, download the Yang models and work with them. But be careful, they are kind of big and complex in the end. Yeah, any questions so far? Sounds pretty easy. Then the idea of the IETF with Yang was, of course, they have some standard Yang models. For example, also for data types, they have Yang models. And then vendors could implement their own. They can make their deviations. They can adapt and say, I support this module, but I have a deviation for example, this option is not available for me. Makes it a little more complicated. Then there was this, or there is this group, OpenConfig, who has the goal to develop vendor-neutral Yang models. So the idea would be, we have one Yang model, for example, OSPF, and if I want to configure OSPF, all the vendors should support this model. I can just send the data, and I will get the data in the exact same way, and work with it. That is the ideal world. Sadly, it's not always exactly like this. Many vendors support the OpenConfig models in a way, in a version, but have then their own deviation versions. So you always have to check if there are deviation models also as available, because you have to merge them together. Otherwise, you don't have the correct API description. And yeah, it is getting better. There are some big companies like Google behind, so they have kind of financial influence on the industry. So there is some, yeah, it is getting better, much better than before, but it's still, you have to try. Normally I would say, if you have one vendor in your environment, try to use the vendor models, because they are most likely the best supported and tested on this device. If you have multi-vendor, I would recommend try out the OpenConfig. If it does not work, then you have to have a dispatcher or something and decide, depending on the model, which the device model, which Yang model you will use. Sadly. So yeah, it is already much better that we have some description of our API, we have structured data, but it's still not perfect. Yeah, here you find all the information from the OpenConfig. There are kind of a lot of models already there. Also not extremely easy to read because they're kind of big. So, the syntax, the important thing. So one thing we have and already have seen is this leave statement, right? So we in the end want to have a value, for example a host name. So a leave statement does not have any children, so it's the last found in our tree structure, has values. So here, for example, we have host name, and then we have here the XML host name. A leave statement itself needs to be in something. It cannot be the top level. So we always need a container or a group or something to have in the end then the leave statement. Leave statement has a type. We have some basic types, but we also can define our own types. We will see that. For example, here we have just a string. We can have a description. It can be nice to know what kind of information we are expecting here, or why do we have this. And also important, and maybe a little special if we combine with other schemas, we have this config field. So we can define, for example, the version is not a config field. I can get the config field, the version field, right? But I cannot just configure it to be another version. For this, I would need to upgrade the device. So this is a state information, so it's not a configuration. We can also have default values. We can say if this value is mandatory or not if we send the data. We can also have the type we have seen. If we use must, we have this XPath coming from the XML schemas, where we can have some Boolean constraints in the end. So we can have a XPath and it has to be true in the end. So we can have some constraints there. We will not go too deep into the constraints because they can get quite complicated. Yeah. All this information here you can also find in the RFC, but I took the time to read the RFC one or twice, so I can give you kind of a summary. But if you want to have the source, then you have to open the RFC. Yeah. Yeah, so we can also have, of course, leave lists, because, for example, interfaces, we will not just have one interface, right? We have most of the time multiple interfaces, so here we could have a leave list, so this can come multiple times. We can also say max and min of elements, so I could define something like I need always 4 interfaces, or I need 4 to 8 interfaces, or yeah, depending what I need. All the rest is kind of the same. We also have then the ordered by, who is for the list, where we can say how we want to order it, but all the rest is kind of the same like a normal leave, just a leave list, another name. Container, we have already seen. Normally a model starts with a container, so that's our entry point, but we can also have multiple containers inside. It's kind of a thing to organize, to group something. So in the XML, this would give us these extra tags to put data inside of this container. A container itself, we have once, so we cannot have, like the interfaces, 2 containers, or in this case, we will not have 2 times this time tags, but inside we can have leave, we can lists, we can have containers again inside. We can also define new data type only in this container, would also be possible. Normally a container does not really provide us some values. There is one exception. We can set the flag presence on a container, so then it kind of means if it's present, it's true. If it's not present, it's false. That's the one exception. But yeah, we could also use then a leave from the type boolean. You have both options. On one side you have the tag, just a tag, then it's a container with presence, or you have a tag with the value true or false, then it's boolean. Yes? Yes, was almost right, but it's not YAML, it's Yang. Yes, yes, it's Yang, and yes, it is just a way to describe our data, the configuration and the operation state to send to the thing. Yeah. So in the end, what we will send if we're using netconf is this block, but the definition defines how this data needs to look. We can verify our XML, we can generate XML. So devices have an option that we can say, give me your Yang model, but communication itself will be the data. So we don't really send the Yang model itself, because both sides should have this. The standard says that the model needs to be able to be pulled down from the device, but normally you have the Git repository where you would get the models, you can work with it, you can check it out. There are online tools like Yang catalog where you can look in which way it has to be. Modern devices, if you make a show command, you can, for example, on the Cisco device, I think since 17.7, if I'm not mistaken, you can have pipe format netconf Yang, and it gives you the configuration, for example, in this format already. So many people are lazy, not really looking at the Yang schema. They're taking the XML, adapt it, send it back. But that would be not really the nice application architecture design approach. But dealing with Yang models in a programmatic way is sometimes a little painful. There are not extremely a lot of good tools who can convert Yang into SDKs, for example, because Yang has a lot of advanced features. The best ecosystem we would have in Golang, because the OpenConfig community, Google, works mostly with Go. So there is the best ecosystem we have at the moment. For example, for generating protobuf definitions from Yang. So we can auto-generate protobuf, and out of protobuf we can then generate Go structs. I will send you afterwards some links to all this stuff. There is also a definition how they make the transfer from Yang to protobuf and what kind of workarounds they used to be able to do that. Yeah. So, yeah. This is the first part is the definition of the data, how it has to look. For example, in our case, it's a uint 8, so it cannot be a huge number, right? But we could also then define this a little more. So hours, we could say, or minutes, we could say it has to be in a range between 0 and 60, or between 0 and 59 actually. But here it's just some examples, so definitely far away from perfect. Yeah, so containers is this tags here to group something, and in XML we always have a top one, so also our model, if we want to use it directly for endpoints, it has to have a container statements on top level somewhere. But you can have includes and all the stuff, so sometimes if you look at models you can't see the containers because this model is just used somewhere else. Yeah. Also here we can say if it's config or not. We have constraints with must. Here with users we can use groups. So if we want to have, for example, an endpoint with IP and port, we could do this in a group and then reuse it multiple times. And the when is another constraint, just not must is a constraint on this object, and the when is one up. Yes. So the question is if we write our own models. It depends. So yes, the device has their own Yang models. Sometimes some devices allow you to bring your own models, so you can, for example, create your model like the service. You say, I don't really care about the configuration, I care about the service, I want to have this VRF or I want to have this VRF. And there are some tools. The most known tool would be NSO from Cisco, who works completely with Yang. So if you want to define something for your infrastructure, you would write your own Yang models. I'm not really writing a lot of Yang models by myself, besides if I have projects with NSO, or if you would take the DevNet expert exam, you would also need to be able to write some models, especially because there is NSO involved. But sometimes, depending how you want to use your tools, you could write the Yang, but mainly you have to be able to read it and understand and generate your data from it. But if you can write, you can also read it. Yeah. Before we saw the leaf list, so if we just have multiple times the same leaf, but maybe we have more complex stuff like an interface does not have just the name, right? An interface will have an IP address, an interface will have encapsulation, MTU, a lot of stuff. So we could have a list element who allows us this kind of things. So in our case here, we have a list of users. They have a name and a full name. There are two famous people here. One is rich, the other one is not rich. Yeah, it's just kind of a container, but it's a list element now. Max element, min element, order are kind of the important properties we could also set. Of course, we have description and all this normal stuff we could also set. The data types. This would be the data types from the RFCs. So different kind of integers, signed, unsigned, integer, decimal, string, enumeration, boolean, bits, binary, and then leaf ref and type def. They are a little more specific or special. Leaf ref, you can have a reference to another leaf somewhere. So for example, if you would have, let's say, a BGP configuration and you want to reference to a loopback interface, hard-coded, you could do that. Not sure if it makes sense, but for example, if you have configuration who needs an interface, you can reference an interface. And the Yang model itself would then validate and see if this leaf is present or not. It's also one of the complex things Yang has. If we want to validate, it is context aware, so we would need to validate or render it multiple times to make all the connections. This is one of the pain points if you want to work with it in a programmatic way and support all the features. Yeah, and the type def is the one on the right side. So here we can define our own types. For example, percentage has to be a value between 0 and 100. Another maybe specific thing to Yang, if we make it type def, we can also then make a new type def on percentage, but we can say now the value is only has to start with a 5. If it would be a string and an integer, we would have to have another syntax. But if we have multiple type defs in a row, or we specify it more and more, all the restrictions we defined will be combined. So especially for strings, if we have a regexes, it will combine all the regex from all the chain how we built the type. Yeah. And then we can of course use this type, and we can also use an import for getting this type from another model like the IETF data types model. Grouping was the example before. If we want to have an endpoint, our case with leaf address and port, this we probably need a couple of times. Or if we make access control list, we have the kind of same data multiple times in the source and the destination. Then we can make grouping and use this with this use statement here. So yeah, for not repeating ourselves all the time, we can do that. And here in the type we see this prefix. So this comes from the module enet, and the data type IP address is actually a string with a lot of regex behind. Yeah, looks pretty simple, right? This is from the RFC then, where we see next week more about netconf. As I said, any transport, then we have RPCs, like we can say set configuration, get configuration, just get for operational data and configuration. We can lock the device, we can unlock the device of course, we can use the candidate store. All this stuff is in the protocol with RPCs. So we will see next week what kind of RPCs we have, how we can deal with it. So let's go maybe to this. Yeah. Nice. Thank you, later. I will fix it and upload it again. Yeah, so here, for example, we have vendor and standard. So if we, for example, have a Cisco lab, we could go here to Cisco. Let's say we have a campus with XE devices, and now you already see a lot of modules, or there are a lot of modules specific on the version we have on this device. There can even be differences on different modules, platforms, sorry. Today my English is a little broken. If we go, for example, yeah, let's just take this one, 17.9.1, we see a lot of modules, right? So there's all kind of modules it supports. And now here we see the deviation models. So all this, for example, this model here is the deviation for the OpenConfig network instances. So it supports OpenConfig network instances, but it has a deviation. So if we just would go here and see the OpenConfig model somewhere, probably more down here, we would say, okay, that's nice, we have this, but we have to be aware there is a deviation. So something in this model is not supported or different. Maybe another data type, maybe some configurations are not possible, maybe some values are not returned. We will have to go into these models. So, and many models here with the Cisco IOS XE are these native models, but they are just used from the main native model. So we cannot use the wireless, for example, directly for the configuration. In Cisco, we have here CFG for configuration and Opper for operational data. So everything that is in a show command normally needs an Opper model to get the operational data, and everything who is configured is config based. So XE VLAN sounds easy. Let's open it. So we have the namespace, we have a prefix, in our case now iOS VLAN. We have import a Cisco model. We have import the IETF ENET types. So for example, where the IP address is defined, we saw before. A lot of imports, different things. And then we have the organization, in this case Cisco, who wrote this model. Contact, but probably if you complain about the model, they will not reply here. So you have to make a tech case. And you have the revision, you can see what is changing here between the versions. And then we have, for example, groupings. And these are most likely used somewhere or in another model. So in this case, on the top level, I would assume we don't have a container. This is grouping. Yeah, this model does not have a top level container, so it is imported in the native model and used there. And we can also have argument, so not only deviations, but we can also have argument who also changes the model. So this model here can also change the structure from here. All these kind of small things are special cases where it makes it more difficult, in my opinion. We also have this statement if feature. So this kind of is a way to disable and enable specific parts of the Yang model. So if this feature is configured in the model on this device, this use statement will be true or false. So you see already why it can be a little tough to work in a programmatic way, because it has a lot of advanced features. But yeah, that's the fun part. A VLAN, for example, here could be shut down. This is an empty type. That's also a way we can do it. We have container, we have empty type, and we have booleans for stuff like this. So we always have to see which model did use which data type or which approach. Enumerations, we can have community or isolated. For the UNI VLAN, for example, we have a container status obsolete, so we could also say this one is obsolete in the model. String, the string can be between 1 and 128. So the idea would be that, for example, if I define the network a VLAN name, that before I send it even to the device, I can validate if it's true, if it's okay or not. If I want to send a VLAN name with 200 digits, my code should already tell me that will not work. Most of the time we could do this. Sadly, in the industry, what I see most of the time is people taking the XML and using Jinja to render the XML. So, because it's the fastest and easiest way, and Jinja is something we know well from the templating with CLI commands, it is many times used to generate XML. Of course, afterwards you still can validate it, if it's valid XML or not. The device itself will also give us an error message or not. If you have, probably in the lab 1 you had a lot of issues where you, for example, configured the IP address, but it did not work because the encapsulation on the sub-interface was missing, or the VRF was configured afterwards. All this kind of stuff who is not really handled nicely by errors. In netconf, for example, we should then definitely get an error message, and we know it worked or it did not work. It's transactional, so we know everything worked, nothing worked. And so there's a lot of stuff much better. So whenever I can, I use Yang and netconf, resconf, gRPC, but it's still not completely perfect. Also for generating the XML, yeah, I did not find the perfect tool in Python yet to make it in an easier way. Of course, we can have the normal XML tools, generate our structure. There is also libraries dict to XML, and we can generate this kind of things, but many times we see people using Jinja for structured data generation. What if you think about it? If you learn it here in the bachelor, it should give you the chills, and afterwards you need to take a shower. But yeah, it's fast, it's easy, and used way too much in the industry. But it's also because of the lack of the tooling, in my opinion. Yeah, so don't worry, on the exam you will not see something like this so big, because I have to pay the printings. But yeah, you can already see here, even for something simple as VLAN, we have a lot of information who could be here, right? So all this stuff with some nice regex, for example, here we can have. So one thing maybe we can also look is in the standard. So all these ones here, for example, are coming from the IETF. We have the official RFC ones who are not in a draft state anymore. You can see there are a lot of them, but not extremely a lot are supported by network devices. So the basic ones, for example, the interface is probably supported by almost all vendors, but a lot of MPLS, I'm not sure. But here we have the types, right? The ENET types, the one we saw before with the IP. This one here. Here we have a lot of type defs, kind of only different types, but the idea was or is that not everyone has to define their own data type IP address, for example, or VLAN. A VLAN will always have the same range normally, otherwise you can still deviate from it kind of and make it more exact with another range command. So the IP version is a type def of enumeration who can be unknown, or it can be IPv4 or it can be IPv6 with a value 1 or 2. We have the DSCP values who will always be between 0 and 63. Port numbers, if you ever have a higher port number than this one, you probably don't have UDP or TCP. AS numbers, there are also different styles. And now, for example, IP addresses. IPv6 address who uses these two patterns, for example. So not everyone has to write the patterns, we can just import this model and use them. But if we want to use a model, we also need to have this model if it's included. So many times we need to see that, for example, if we use pyang as a command, that all the models we need are in the search path. Sometimes it's the easiest to just copy all the files in the same level and use it, like on the device. If you get all the models, you have really everything on the same level. There are a lot of different IPv6 prefix, for example, where we don't have to go through all of them. It's nice if they have a description, you can read it, but yeah. I had my fair share of experience with Yang. There is one project, it's called Pydentify. Let's see if Google knows this project, or Bing in this case here. Let me see. Oh, it knows at least the package. Also here. So this tool here, let's go to the welcome page, is a tool with the goal to generate Pydantic data models out of Yang. So this project was started because of the lack of tooling, how we can nicely deal with Yang in Python. There would be PyYang bind, who was for a long time not maintained. At the moment I think I have 2 maintainers again, but I was never really comfy with the data structure it generates, with the objects, how to deal with it. I am a big fan of Pydantic with the data model, all the stuff. So this tool here is was the idea. And who developed this tool was a was a student midterm thesis from here. So one of your former colleagues or 2 developed this tool. I took over the maintenance now. It's not really maintained because of lack of time, but I will definitely in the future continue, because in my opinion there is not a really good tool to deal with this at the moment. So here we have a simple model. We can use this tool and it generates us this Pydantic model here with the top level with all the descriptions. So if you work with it in a VS Code or in a PyCharm, you can have the code highlighting, you can have auto-completion, and you can have the tooltips and see what kind of is here. So here we have endpoint counter, who then has an address, port, and description. And because of all this comments here, if you would have the tooltip, you can just see, this is a port from the type port leaf. Then you have to go to the port leaf. This is Pydantic version 1. This will be changed as soon as I have time to update to Pydantic version 2. There was just a change there. But you see the idea. And also the limits or the range for integer or the regex for strings are taken into account, so the model itself will validate the data. But for example, the whole context validation is not possible because you have to render it multiple times to be sure. So it has just some basic support at the moment. Any questions? Next time we will see more about the protocols, how to interact with the devices. The lab now is more about Yang, to write a simple Yang model, to see how it works, to also open some of the Yang models here in this repository. So if there are no further questions, thank you very much.